Hello and welcome to this video about the union and intersection of events. In this video, we will introduce these basic operators that we will use a lot to deal with different events and to combine the probabilities that are linked to each of them. First of all, we will begin talking about the union. The union is something similar to the addition, and we refer to the operator or to refer that we are interested in the probability that A or B, they are happening both at the same time or any of them. So when we talk about the union, we accept the case that A is happening alone, B is happening alone, and also we accept the intersection, which is the area that lives at the middle of both. There is another definition, which is the intersection of events, that includes only the area where both events are overlapping. So in this Venn diagrams representation, you can see that the intersection of events includes only the common area between the areas of events A and B. We refer to the intersection of events with this operator that's shown in the slide. And also we consider that the intersection of events refers to the multiplication using the algebra for events. We need to define an idea that will be extended later, which is the idea of mutually exclusive events or incompatible events. We talk about mutually exclusive or incompatible events if they have no outcomes in common. So, in other words, we say that the intersection doesn't exist. Here, we can see the definition for two events, A and B will be exclusive if the intersection between them is the empty set. So, nothing is included in the intersection because it cannot happen. But more generally, in this course, we will work with partitions of events that can be represented as A1, A2, AN, where NN represents the number of partitions that we are doing of the sample space. Imagine that we are talking about D8 and we define a partition of D8 as having less than 18 years. And there is another partition, this is A1, having less than 18 years. And also we have A2, having between 19 and maybe 24 years. And there is another partition which is A3, which is 25 to 30. So we define different partitions of data, and we will learn how to combine these partitions with other events that may be interesting for them, such as, for instance, I don't know, having smoking habits or having a pet job and so on. So here we are defining the idea of mutually exclusive events as partitions of the sample space where the intersection between them cannot happen. So you cannot have at the same time an age that's classified into less than 18 and also more than 24. So here you see the representation, here you see two events, A and B, and you may see that the intersection doesn't exist. Let's see an example. We have two events defined over the phenomenon of throwing the dice. You know that the sample space for this phenomenon is the set of numbers from 1 to 6. So we define two events, which is event A, number roll is even, and event B, number roll is at least 4. So you will see, it's easy to see that the set of numbers that fulfill the definition of event A is 2, 4, and 6. And also for B would be the set of numbers 4, 5, and 6. You know that the sample space for this phenomenon would be the set of numbers from 1 to 6. This is something we already said. And now we can define the complements or the intersections between them. So the complements, no A, would be the set of numbers that are not included in A. And also for no B, would be the set of numbers that are not included in B. Between this set of numbers, we could define the intersections A and B. We can see that the intersection between A and B is the set of numbers 4 and 6. Why? Because 4 and 6, as you can see in the sample set, 4 and 6 belong to each of the set of numbers included in A and also B. They are present simultaneously at the same time. This is why they are classified in the intersections. And we could even try, in draft, you can try to check that no A and also B, the intersection is only number 5. We could define another combination where the intersection doesn't exist, and that would be the case where we have mutually exclusive events, also incompatible events. But as regards to events A and B, the intersection exists, and that means that they are not mutually exclusive events. That's very important. For the union, as you can see here, the union is defined as A or B, and as we are accepting numbers that are included in A, B, or both, we are including 2, 4, and 6, which came from A, and also we are adding number 5, which came from B, and of course, those numbers that were present in both sets are again included in this union. So the union includes a higher number than the intersection. This is very important when we consider the addition rule. If we think about the probability that A or B they are happening, that means only A, only B, or both. If we work with incompatible events or mutually exclusive events, then the probability of both, the probability of the union, will be only adding the probability of A plus the probability of B, as it is written there. But if A and B are not incompatible, means that the intersection is not the empty set, that means there is something in the intersection, you will need to consider the addition of P of A plus P of B minus the probability of P of A and E, probability of the intersection of both events. That's very important because the addition rules changes according to the type of data that we are combining. This addition rule could be extended to 3 or more events. In this course, it doesn't make sense to worry about problems that combine 4 or 5 or 6 events. This is not our objective. But it's interesting to see that the addition rule can be extended to 3 or more events. We just have to eliminate as many times as needed the number of double intersections. And maybe here, as we are extracting 3 times the double intersections, there is like an empty set at the middle of these 3 events, and this is why we need to add again the third order interaction between A, B, and C. But this is something that you don't need to reason the day of the exam for the evaluations. These are standardized formulas that will be available in the formula sheet. And you just need to know when to apply one or another. So here you can see a representation of how it works. So for the union of non-incompatible events, we need to consider the area of A plus the area of the intersection of both plus the area of B. This is a representation of this union, addition rule. So with this, I finish this presentation about the union and intersection of events. I hope you find it useful for the resolution of problems. Thank you.